Hi class, we've talked about Newton's first and second law so far and unbalanced and balanced forces. The next on our list is Newton's third law of motion. Let's watch this intro video before we get started on our notes.
Till now, we've only learned the first and second laws of motion. Oh, you're riding a bicycle. Have you ever wondered why a bicycle moves forward? Well, it moves according to Newton's third law, which says that for every action, there is an equal and opposite reaction. To understand this, see what happens when you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction. Action, reaction. Together, the floor and the ball form what's called the action-reaction pair. So now how it applies to your bicycle. When you push the pedal, the parts of the tire which touch the ground push it backwards. The ground also pushes the tires forward with the same force. So Earth form a pair of action and reaction. So what happens to the Earth when your tires are applying force to push it backwards? Huh? Oh, nothing happens to it, since the Earth is very big as compared to your bicycle. The force applied by your tires does not move it backwards, but force applied by the Earth pushes your bicycle forward. So now you understand Newton's third law. Yep, the tennis ball is the right example. The ball and the floor are creating a pair of action and reaction.
The video used a couple examples of a tennis ball and a bike. In those two examples, there was a force that was equal and opposite to the action. So that is called the reaction force. So according to Newton's third law of motion, forces always act in equal but opposite pairs. So whatever force you are exerting, there is some force acting back on your force. So that is called the reaction force. If you take a look at your notes, you'll see the box at the top, which is where we're going to put our definition. So according to Newton's third law of motion, okay, we can put for every action, there is an equal and opposite reaction. So please get that in your notes. So for short, we call Newton's third law of motion the action-reaction law. Then at the bottom of that, it says action and reaction forces don't cancel. So they don't cancel each other out. It's not like one force cancels the other out, which means it doesn't happen anymore. You're still doing that action. It's just another force pushing back on you. So when you jump, you are pushing down on the ground. So you push down on the ground. Okay. Then the ground pushes up on your feet. Okay, this upward force is what pushes you into the air. So think of it as when you are jumping, you push off down into the ground and then you spring up onto your feet. That is an action reaction. So get those down into your notes. You can pause the video if you need to. Right? Another way of saying this, like I said, is there is any type of action you have, there is an equal but opposite reaction. So if you push on a wall, the wall is actually pushing back on you with the force and equal strength to the force that you are pushing on that wall. Now the wall doesn't have arms and it's pushing back on you, but it is pushing against your force, causing an equal and opposite reaction. And again, action and reaction forces don't cancel. They are the action-reaction force pairs. Either one can be called the action. It's usually the one that the human is doing that is called the action. So here's an example of a person jumping. Okay, so whenever we're moving around at recess or at home, when we jump, we are pushing down on the ground. The ground is then pushing you up, and that is what is pushing us into the air. So we're going to get into some sketches now. So if you want to, you can pause the video and try to draw them before we start talking about it. There are three examples: a bird flying, a person walking, and a rocket launching. Okay, so I want you to draw those images in those boxes and try to draw the action-reaction forces that are acting on that image. You can just draw them with arrows and write action-reaction beside them. So, when a bird flies, its wings push in a downward and backward direction. This pushes the air downward and backward. We know, because of Newton's third law, that the air pushes back on the bird in opposite directions, in an upward and forwards motion. This is what keeps the bird in the air and propels it forward. So when a bird flaps his wings, they're pushing downward and backwards. And then in return, because of the action-reaction law, they are moving forwards and up into the sky. So hopefully your bird has some arrows going up, down, forwards, and backwards as best as you can. Again, you can pause the video at any time to get your drawings down. They did mention in the one video that your shoe or your bicycle pushes down into the earth, and because the earth is so big, the earth doesn't actually move, but it gives you the sense of large objects and small objects. So when you walk forward, you actually push backwards on the ground. The earth is so big that it's not going to move the earth, but the earth then pushes you forward. Obviously, if it was an object that was smaller that we were pushing on, we would actually move that object. But because the earth is so big, we don't push it backwards when we walk. And that's because it has so much mass compared to us. But an example of something smaller was if you step backwards onto a skateboard, the skateboard's going to push backwards when you go forwards. We'll skip the walking image and we'll go over that tomorrow in class, but the rocket launching. So in your rocket launching picture, you have hopefully an image that looks like there's something coming out of the bottom, so that rocket fuel is ignited and a gas is produced and it's pushing out of the bottom. Then you have the walls of the rocket pushing out and down, and then in turn your rocket is going to go up and out of that area. So we have forces pushing down, which is that action, and the reaction is that it is causing the rocket ship to go up. All right, so that downward force is the action, that downward push is the action, I should say, and the reaction is being pushed upwards by those gas molecules. We're going to end on this slide with measuring weight. So at the same time Newton's third law is occurring, it happens also with our weight. So this force is our gravity. Okay, so if you're standing on a scale, like this girl here, all right, she's standing on a scale, putting her weight into the scale, and that force is being exerted, and gravity is pushing down on her as well. So remember when we said that weight is the amount of gravity being pushed on us, whereas mass is the amount of matter in an object. So when you stand on a scale, your weight pushes down on the scale, and this causes the scale to point to our weight. So it has a lot to do with how gravity is forcing or is pushing us down as well. So it's that downward pull of the gravity. So at this time, you're going to get out, you're going to grab a paper from the substitute, and it is on Law 3, so it's another one of those mini posters, and you can work on it with a partner. You're going to label action and reaction pairs. You're going to get down the definition and explain how animals move in terms of action and reaction pairs. When you're done with that, you're going to work on MCL and make sure you're working quietly and efficiently.